Hey kids,
Yeah?
have you ever wondered how much energy goes into buildings?
No.
Well, we're going to analyze that. But we're not only going to analyze how much goes into any old building, we're going to analyze the amount that goes into the record tallest building in the world. So first we need to ask ourselves, how much steel do we need? Well, we know that the current record holder, the Burj Khalifa, stands at 828 meters. That's 2,717 feet for those of you using standard. Our building will use X-bracing tubular trusses to build our skyscraper, the most efficient method of building, at 145 kilograms of steel per square meter. Before we calculate steel, we must first calculate the square footage of the building. Basing ours off the Khalifa, we take the total square footage and divide it by the height to find the average per meter. After that, we can take the height, 829, and multiply it by our average, 373.75, to get a total of 300,009, 846.76 meters squared. Finally, we can calculate the necessary amount of steel to build the tallest skyscraper by multiplying square meters by 145 kilograms per square meter to get 444,927,708.15 kilograms of steel.
Okay, so we can build it now, right?
Whoa, hold your horses. We can't build it yet. We first need to find out where the steel comes from. So, in order to transport it from site to site, we have to bring a whole whopping 44,927,780.15 kilograms of steel, and the average flatbed truck can only carry 46,000 pounds at a time. So, to calculate the amount of trips that need to be taken from site to site by one truck, we need to change the weight of the steel to pounds. 1 kilogram equals 2.204 pounds. Now we'll take that number and divide it by 46,000 pounds, and we'll see that it will take approximately 2,153 trips. We will now use this mathematical equation to calculate the energy it takes for the truck to move non-stop from the steel mill to the construction site one time. The initial velocity, VI, is 0 because the truck is not moving at the beginning. The final velocity, VF, is calculated by using the equation velocity equals distance over time. The distance from the steel mill to the site is 2.05 miles, and according to Google Maps, takes 11 minutes. So, after doing the maths, it comes out to about 0.186 miles per minute. After multiplying this number by the amount of trips, we get that the entire amount of energy is 15,217,404 joules. So, it takes 44,927,780.15 kilograms of steel to make this huge building. But let's look at what goes into making the steel I-beams, C-beams, and box beams, and other sort of beams themselves. In order to transform the steel from the massive sheets that we have, we need to use a process known as hot rolling to transform it into the many beams that we know and love. It takes around 2 to 2.4 gigajoules to produce 1 ton of steel via hot rolling. However, by doing this process, we actually lose 18% of the amount of steel that we started with. So, by multiplying 44,927,780.15 kilograms of steel by 82%, it comes out that we have 54,789,975.79 kilograms of steel originally. But don't speak too soon, because 10% of that was actually lost while smelting steel from the iron. So, by multiplying 54,789,975.79 kilograms by 10%, it actually comes out to 547,899,757.9 kilograms. And by multiplying that and transferring it into megajoules, it comes out the total energy to Smith and smelt iron into steel takes 10,958,000,000 megajoules. But you can't get iron from nowhere, and yup, when you smelt that from iron ore, you lose 10 more percent. So, 547,899,757.9 kilograms of steel actually turns out being 5,478,977,509 kilograms of steel. And when you multiply that and convert it into the amount of megajoules needed to smelt that, it comes out to 109,580,000,000 megajoules. Wow! But even the iron ore doesn't come from anywhere. It comes from the ground, and we have to drill it. And yep, 15% of that is lost because we're just darn inefficient. So, 5,478,997,579 kilograms of steel becomes 36,526,600,000 kilograms of steel. And it takes energy to drill. It takes about 6.408 watts to mine 1 kilogram of iron. And when converted, that means that for our total amount of steel needed, we need 842,626,100,000 megajoules of power and work in order to go into our building. So all in all, it takes 10 trillion joules in order to make the tallest building in the world. That's a huge amount of energy. To put it in perspective, it takes 4.184 times 10 to the 9th joules for every piece of TNT. That means that for our entire building, it would need 24,000 tons of TNT to match the amount of energy. That's even more than the atomic bomb, the Fat Man, that was used in World War II. Hello. Look at your physics project. Now back to mine. Now back at your physics project. Now back to mine. Sadly, yours isn't mine, but it could be yours if you used this wonderful Sharpie that we used to draw it in and then did the exact same thing that we did. But you didn't. Look down. Back up. What's in your hand? It's a pool of physics equations. But sadly, it is not yours because it is mine. Ha ha ha, screw you. For those of you using standard. To make our building, we'll use X-bracing, shit. So first we need to ask ourselves, how much steel do we need? We know that the tallest building currently is 828 meters. That's 207, Velocity equals distance over time, where d is distance and t is time. That's why I just said it. In order to find the mass, we add the weight of the load in the truck to the weight of the truck and get around 76,000 pounds. Now, after plugging that all into the crazy equations we have, we get a total of 7,068 amounts of work put into moving the plate. So, we know it takes 400, damn it. So, it takes 400, dang it! In order to transform the giant lumps of sheet steel that we have to use a process, God dang it! In order to create the steel, turns out to be 36,526,000,000,000, damn it. And it takes energy to drill. It takes about 6.408 watts per pound, measurable amount of steel. That's a huge amount of energy that goes into building a building. To put it in perspective, it takes about 1 times 10 to the 14th power of joules for every... No, that is not it at all. Never mind, ignore me. So all in all, it takes 1 times 10 to the 14th power of joules